alone. I'm a broken home. I gave you all the bricks that I own and know. I'm letting go. I'm breaking these walls down, breaking these walls down. If you want adventure, then fly to home. But if you wanna travel, then go alone. Yeah, what's the point in us if I never know?
Diawali dari keinginan pemerintah Indonesia untuk memenuhi kebutuhan sumber daya manusia di luar Pulau Jawa, berdirilah sebuah perguruan tinggi negeri di jantung kota Balikpapan bernama Institut Teknologi Kalimantan. Diresmikan oleh Presiden Republik Indonesia ke-6, Susilo Bambang Yudhoyono pada tanggal 6 Oktober 2014, Institut Teknologi Kalimantan memulai kegiatan akademik dengan menerima mahasiswa baru sejak tahun 2012. Dan terhitung sejak 5 September 2019, jumlah mahasiswa Institut Teknologi Kalimantan adalah sebanyak 4.074 mahasiswa. Desain infrastruktur, pengelolaan sumber daya air, dan manajemen proyek konstruksi dipelajari dalam program studi teknik sipil. Identifikasi potensi masalah wilayah dan kota, serta menyusun rencana tata ruang didalami dalam program studi perencanaan wilayah dan kota. Pada program studi matematika, selain mempelajari aljabar, geometri, dan analisis, matematika juga berpeluang untuk mempelajari statistika, komputasi, aktuaria, dan riset operasi. Institut Teknologi Kalimantan juga menginginkan lulusan yang dapat berperan menjadi konsultan dan sistem integrator, database specialist, dan IS academician yang dilatih dalam program studi sistem informasi. Prodi Informatika mempelajari bidang dasar informatika, pemrograman komputer, serta mampu mendayagunakan, mengevaluasi, dan mengidentifikasi pengembangan sistem.
The Honorable Prof. Insinyur Budi Santosa, Purwokertiko, PhD as Director of Kalimantan. The Honorable
Ms. Barkaton Hasanah, STMT, as the coordinator of the study program Electrical Engineering in Kalimantan Institute of Technology.
Dear Mr. Dr. Hawang and Dr. Happy Aprilia, as the presenter on the today webinar.
The Honorable, all lecturers and all civitas community in Kalimantan Institute of Technology.
The Honorable Mr. or Mrs. from sponsorship and donors of this event and the participant of the webinar this morning, this we are proud of. On this session, we would like to thank the sponsor and donors the National Innovation Factor event. The first into PT PJ Upjum Kaltim, to the Hotel Pacific, to the Zigzag Coffee, to the STM Education Group, and the last Emarif Confection. Assalamualaikum warahmatullahi wabarakatuh. Salam Om Swastiastu, Namo Buddhaya, Salam Kebajikan, and good morning, ladies and gentlemen. Welcome to the international webinar, Pejuang Inovasi Nasional 2020 Electrical Engineering Institute Teknologi Kalimantan. First of all, praise the Almighty God for the blessing we are able to attend this international webinar held by Committee Pejuang Inovasi Nasional 2020 Electrical Engineering Institute Teknologi Kalimantan with the theme Energy Optimism and Economic Crisis, Great Solution for the Better Future. Permission to introduce myself. I Feli Arkanur, a college student of electrical engineering.
And I'm Yosefiana Aboseko, student of electrical engineering.
We as the master of ceremony of the webinar today.
Okay, next we will read a rundown of the webinar on this morning. Before, we would like to thank you to the sponsor and donors of the event, Pejuang Inovasi Nasional 2020. Okay, this morning rundown are opening, Sing and Song Indonesia Raya and Mars ITK, welcome speech, sharing session and discussion webinar, question and answer, wording, and the last is closing. Before we start today's webinar, let us all recite Basmalah.
Bismillahirrahmanirrahim. Let you sing the songs Indonesia Raya and Mars ITK. Next is a speech from the Rector of Kalimantan Institute Technology to Prof. Insinyur Budi Santosa Purwokartiko, PhD. The time is yours.
Thank you. Good morning, everybody.
Morning.
Morning.
Honorable Speaker, Dr. Huang, from Monash, Dr. Huang from Monash University. Welcome to international seminar, international webinar by Electrical Engineering ITK, Institut Teknologi Kalimantan. Thank you for your willing to share your knowledge for this webinar, Energy Optimism Amid Economic Crisis. Great solution for the better future. Yeah, this topic is very interesting. I think it will give us much new knowledge how to maybe create new energy resources or renewable energy. So it will give us better environment for living. Thank you for the local committee for doing this webinar. So even though we have COVID-19 pandemic, we still can do some significant works in the academic aspect. So this pandemic season or time, we still can learning some new knowledge, and hopefully this kind of webinar can be done continuously. So because this type of webinar, I think, is more efficient and still effective. So we don't need to use a complicated way to do some seminar. So I think this is the new solution for having international seminar through online meeting. Yeah. Okay. Do I need to open this event, Fairly?
Okay. Thanks to Mr. Prof. Insinyur Budi Santosa Purwokartiko, PhD, for the speech.
Oh, okay. Yeah. Okay. I hope this seminar and this webinar will be successfully giving us knowledge and beneficial, so we can do something new which is give a benefit for us. Okay, thank you. Selamat melaksanakan webinar. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you. And the next is, today's webinar will be guided by a moderator who is also a lecturer of electrical engineering in Kalimantan Institute of Technology. Let's go to the main event. The material delivery session today's webinar will be guided our moderator. Please welcome our moderator, to Mr. Kari Sugiarto. Time is yours.
Okay, thank you for the opportunity given to me. The Honorable Rector of the Kalimantan Institute of Technology, Professor Budi Santosa Purwokartiko, PhD. The Honorable Chief of Coordinator of the Electrical Engineering, Ms. Barokatun Hasanah, Magister of Technology. The Honorable in charge of the PIN 2020, Mr. Vicky Andrian Kusuma, Magister of Technology. The Honorable, our keynote speaker today, Dr. Happy Aprilia and Dr. Huang. and my fellow lecturers and international webinar participants, thank you for joining this webinar. Our theme today is Energy Optimism Amid Economic Crisis, Create Solution for the Better Future. Good morning to all of us. Before we get the first session, allow me to introduce myself. I am Hari Sugiarto as a moderator for this event today. I am a lecturer in electrical engineering at the Kalimantan Institute of Technology. In this international webinar today, we have two speakers. Let me introduce the first speaker, Ms. Happy Aprilia, Doctor of Philosophy. Education, Bachelor of Applied Science in Industrial Electrical Engineering, Electronic Engineering, Polytechnic Institute of Surabaya. Master of Engineering in Energy, Asian Institute of Technology, Pathum Thai, Thailand. Magister of Engineering in Power System Engineering, 10 November Institute of Technology, Surabaya. Doctor of Philosophy in Electrical Engineering, Nasional Cheng Kung University, Tainan, Taiwan. Work experience, tutor of AutoCAD training, EPIS ITS Surabaya, Indonesia. Teacher School Private course in Surabaya. Lecture State Polytechnic of Samarinda. Permanent Lecturer of Kalimantan Institute of Technology, Balikpapan, Indonesia. Award and honors. Best percentage of Brawijaya Electric Vehicle Competition. Second runner-up in Thailand. First runner-up in Thailand. Award of Pendidikan Pasca Sarjana Luar Negeri, Scholarship, Joint Degree. Award of Indonesia Endowment Fund for Education. Best Present in Indonesia Scholars Sensitive Summit, Taiwan. Favorite winner Indonesia Independent Day Podcast. Next, the second speakers, Mr. Dr. Hawang. Education, Bachelor of Engineering in Electrical Engineering Automation as China University of Science and Technology, Shanghai, China. Master of Science in Control Theory and Engineering, Shanghai Jianghota Tong University, Shanghai, China. Doctor of Philosophy in Information Engineering, the China University of Hong Kong. Work experience, part-time research assistant, Department of Information Engineering, the China University of Hong Kong. Washington Research Foundation, Innovation Fellow, Clean Energy Institute of Department of Electrical Engineering, University of Washington, Senior Research Associate, College of Business, City University of Hong Kong, Postdoctoral Research Fellow, Department of Civil and Environment Engineering, Stanford University, Lecturer, Department of Data Science and AI, FIT, Monash University, Australia. Scholarship and Award, Schneider Electrical Scholarship, SG2. First Class Scholarship for Academic Excellence, National Excellence Scholarship, China. Postgraduate Scholarship, Innovation Fellowship, University Washington. On international webinar, there are rules. The first webinar will be conducted in 2 hours. Second, each speaker is given 16 minutes to speak. Third, there will be 3 question art session. 4, question can be written in the comment box in English. Okay, let's start to first section with Dr. Happy Aprilia with the title The Role of Academic and Readiness of Research in Energy Management and Development. Theme is yours.
Okay, thank you, Mr. Harris, for the introduction. So, does anyone hear my voice clearly?
Yes, clearly.
Okay. So let me share my screen. Okay, so do you see my screen?
Yes.
Okay, thank you. So let me begin my session. Thank you everyone, and thank you for the committee of Pejuang Inovasi Nasional 2020 for inviting me as a speaker in this international webinar. Today, I would like to deliver a topics about the role of academics and resources readiness in energy management and development. And because I'm an electrical engineer lecturer, so it will be based on my perspective as an electrical engineering. And let me introduce myself again. My name is Happy Aprilia, and I will be happy to deliver these topics to you. So let me start my presentation. If we talk about the academics' roles in the energy management system, at first we need to think about what is the academics itself and what is the resources. And the academics, many people think that it is a formal degree that we can gain a skill, we can gain knowledge, and can learn about the technology. And what about the resources? Now, the resources is anything or an assets that can be integrated to have an effective goals like that. So if we talk about resources, it's not a single word, but it can be defined as this: the natural resources like vegetation, animals, soils, minerals, water, or maybe the human resources, right? And another thing is maybe the energy resources that come from the renewable energies or any fossil energy. And in academics life or in formal education, all of us will learn about the specific things or specific knowledge and skills about these resources. But then the question is, when we already learn the basic idea or the basic technology of all of these resources, and how do we use it? How do we integrate the skills, the knowledge, and the resources? So we need to come back in a perspective of the long-term academic program school. Like in this picture, actually, when we already have the basic idea of those skills and resources, it's again up to us. How do we manage this information together to build a better world, right? And long-term academic programs at various qualification levels should provide skill required to develop and promote energy concepts in the context of sustainable development. So it should be sustainable. And if we talk about sustainable development, we will come to the Sustainable Development Goals by the United Nations, in which the goal itself is actually known as global goals that adopted by all United Nations member states. And what is the goal actually? It wants, the SDG, Sustainable Development Goals, want to end poverty. And then the goals also want to protect the planet and ensure that all people can enjoy peace and prosperity. And the goals is a very big goal, right, for our future. And this goal is break down into 17 actions, in which each actions, the outcome will affect another actions, like that. And we cannot just do this action, these goals, one by one, like that. But it need to be integrated as one to have the goals achieved in 2030. And if we talk again, now we have a broader idea, we have a broader goals in which we need to achieve the sustainable development goal, right? Oh, sorry, I hope you can see. So then in academics life, we learn the technology, the skills, and the knowledge. And when we graduate, and then we are facing the real problem, right? It's not only about how do we know about the technology, but how do we choose the best options for the real-time problem? Just like this figure, in which we need to find what is the right technology for these resources. Now, if we want to choose what is the best option or what is the best strategy for the real problem, we need to think about the resources itself. And if we talk about the resources, we talk about the resources availability, the quantity and the quality. How much resources are available and how much resources we can access to. And then again, about not only about the quantity or quality of the resources, we need to set the purpose also. What is the purpose of this energy use? Is it good for the environment or is it good for the economic reason? And that's why we need to mapping. We need to have a map to the potential resources and the quality, so we can find, we can match these resources, the technology, and to achieve a goal like that. And if we talk about the integration of all of those, we also need a broader perspective in which we need to think about the growth of the application, the growth of the implementation, and the inclusiveness, who will be the actor of this kind of strategy. And then, will it last for a long time? Will it sustain for a long time? And who are our partner? What is the innovation that they want us to solve like that? This is actually the perspective when we talk about how the academics need to manage the resources. So all of us need to have a broader figure, broader picture like that. And then, can academia work alone? If we, in the school, in the university, all of us has taught any skills, right? Maybe the mathematics, or maybe the English, or maybe the physics, like that. Or maybe I'm the scientist of PV, renewable energy, just like that. But then, can we just depend on those skills? Not really, right? the implementation in the real phase problem is depend on the policy and also the quality of the resources. And in this case, the stress is on the human resources. It's like this figure actually. This figure illustrates that, wait a moment. This figure is illustrating that we already know the technology, but somehow the government didn't really support this kind of implementation. So that's why we need to change our mindset to a broader goals in which support the sustainable development goal. And because of that, we will come to the era in which there are freedom to learn. In Indonesia, it is called as Merdeka Belajar. I'm sorry, this one is it is covered, right? So that's why Indonesian government made a good project, made a good policy about the students, about the university students, to not only learn about the technology, the knowledge in a school, but also try to correlate their skills in a real world problem. And that's why there's a freedom to learn here. And the freedom to learn has 8 key performance indicators. The first one, by having this kind of scheme, the graduates can get a decent jobs because the skills not only about the technical skills, but also the social and interpersonal skills, like maybe becoming entrepreneurs, becoming a technopreneurs, and gain knowledge from, industrial collaboration, something like that. And the students are earning off-campus experience by having this internship, community projects, teaching, research, entrepreneurship, and also student exchange. And for the lecturer also, we will gain some benefits because we can also have a collaboration with the industry or outside the university. And the practitioners or the expert from the industry or from the community can teach at the campus. And lecturers' achievement and innovations are utilized by community and recognized internationally. And in the curriculum quality, by having the freedom to learn, we can also improve this curriculum quality because there's a cooperation between study program with the international level partners. There's a collaborative and participated class. And also there's an international standard for each study program. So we are going toward that kind of goal, in which we can improve our education quality by having the improvement in graduates quality, the lecturers and tutors, and also the curriculum quality. By what? By integrate not only the knowledge, but also the experience outside the campus. So by that, as a student or also as the lecturer, I think, and also the industry, now we are not work alone. We need to have a collaborations to achieve a goal of 5P here. We have inclusiveness in the people. We can keep our planet safe. We can distribute the prosperity. So there will be no poverty actually if we try to have a sustainable development goals. If these SDGs can be achieved, And also, by having a work together, we can maintain the peace and also the partnership. So everyone will have benefits, right? So as a student here, we not only, how to say, study in such small topics, but try from now on, we need to try to correlate with another topics, social topics, economic topics, or environmental topics. So we can have a compact idea and solutions for all. Yeah, that's actually what my aim, to have a sustainable development goals in every aspect of our learning. And because I'm electrical engineering, so wait a moment, I don't know how to, can you see this? Because I'm an electrical engineering, I will introduce you. In electrical power system, we have a term called smart grid. Actually, this smart grid is an intelligent with automatic device power system. Why we have this kind of breakthrough algorithm or breakthrough scheme? The smart grid actually just wait. Okay. Maybe I will just, I'm sorry for the technical problems. Can you see it? I think it's still okay, right? So smart grid is an intelligent with automated control and monitor system. And as we see here, actually the smart grid is just a power system, but equipped with the automated control and monitor system. If we see, this is just generators, all kind of generators. There's a wind power plant, solar power plant, and transmissions going through the distribution systems, right? And all of these generations are integrated in one energy management system. And after that, all informations will be managed in EMS. We call it energy management system and the EMS will try to dispatch and distribute the power based on the demand. And smart grid technically is just a concept for the conventional grids with some latest automated features which make them more reliable and sustainable. So what is the application of the sustainable development goals in power system? Can we incorporate, the SDG in the power system? Yes, we can, by having this smart grid. So smart grid actually is just a conventional power system, but equipped with the automated control and monitor. That's why we applied the sensors. We applied the information technology here. Why do we need this? Because we want to achieve this goal actually. We want to achieve the security in power system. We want to have electric storage in power system. We want to have, by having this too, we want to have a reliability. It means like there will be no blackout, right? Because we have abundant amount of power. And we want to have a demand response in our smart grid. And also by having these four, we can achieve the sustainability and we are freedom to communicate, not only from the power generation to the distributions, but because there's a renewable energy, the distribution can also support the power to the EMS, right? So the communication will be two ways right now. And in smart grid, we also incorporate the microgrids as small grids. So in smart grid right now, there will be not, not only from a bulk power system to the distributions, but now it can change the directions. Even in distributions to the bulk power system, they can have cooperations. I think that's the idea of smart grid. And by having this smart grid, it enables some kind of features. I mean, by having the sensors, the information technology to a bulk power system like that, this kind of scheme will enable or will results a very big data, right? We will talk about not only the power, but we talk about the data because we need to monitor this data. And after we have this big data, what do we need to know? We need to analyze the data. So by having the smart grid, we enable a grid measurement, we enable the utility information system, we can attach the external information systems like weather, financial, the crisis feeds, the social media, and we can do the analysis. And this analysis will be subjected to a data visualization. I mean this one. So after we have a very big data, we can analyze and we can have a decision. What will we do next? So it is just like a SDG goal. It's not about today, but it is about it is about the tomorrow, or the day after, or the month after, the year after. Not only about today. So this smart grids enables the data analysis, so we can have decisions toward this big data, and for a next planning like that. I hope you can get it. So again, what is the key technology of the smart grid? Actually, if we see this, because we talk about the reliability, the demand response, electric storage, and sustainability, communication like this, how can we have an independent resources? If we go with that idea, that's why we need the renewable energy. Because now the base is not only about the bulk power system, like a thermal generation. No, we can have a microgrid, and microgrid can also be done by having this small and independent amount of renewable energy. By applying the renewable energy technology like wind power, solar energy, wave power, hydropower, biomass, geothermal energy. And what is the renewable energy? Renewable energy is as those derived from natural process and replenished at a faster rate than they are consumed. And the renewable energy includes all forms of energy produced from renewable resources in a sustainable manner, including bioenergy, geothermal, hydropower, ocean energy, solar energy, and wind energy. So the key is, it is derived from natural process, replenished at a faster rate than they are consumed. We can consume now, but tomorrow it will grow again. So there will be no end for this kind of energy. And it will also support the goals of sustainable development goals, right? Okay. That's for the renewable energy. And again, one key performance of smart grid is a demand response. Now, we're not talking about how the power system can support the demand, But we can also have a control in demand. We can have a control in the distribution side by having this demand response. If we take a look at this, the base case is we have some kind of energy consumption within a day, and we can have a control by having a peak shaving, in which in the peak time we try to cut the energy consumptions. And maybe if we don't cut the energy consumption, we can have a support from renewable energy to supply the energy needs in this duration. And again, another type of demand response is the conservation or energy efficiency, which defined as the less amount of energy consumed within a day. If the normal one is here, so we try to increase the efficiency of the electrical equipment so the energy consumption can be reduced. Okay. And another scheme of demand response is the load shifting, which we know that, if we, I don't know, in Indonesia, there's a different price, right, between off-peak and peak time. So there will be a different price of electricity in off-peak, this region, and with the peak time, because in peak time the price will be higher than the off-peak time. That's why load shifting can be a solution for that. So we try to move this peak consumption into the off-peak time. To get what? To get a benefit, of course. Okay, how can we achieve that kind of demand response? One of the support is by having the energy storage system. By having the energy storage system, it is called battery actually, we can apply the peak load shaving technique because we want to cut the consumption in the peak time, right? But we want to have we can utilize the energy that have been stored in the battery actually. It is the mostly used energy storage system for peak shaving, and by having the BESS, the power quality of the grid can also be improved. So this one actually, if we see this, we know that the energy consumption will have this kind of curve, and by having the battery, the BESS, we can supply this kind of energy needs in the peak duration with the energy from the battery. Okay. And again, I want to remind you what is the smart grid, because smart grid, we will have a big data and then we can analyze this data and have a decisions. And actually it can be applied in the planning and operation of a power system. And here, if we have electricity markets and we have electricity commodities, we want to supply an energy to the system. But if we want to aim for a high profit like that, we can bid in a day ahead market, right? And by having a bid, that's why we need to have a preparation. That's why we need a forecasting algorithm actually. The forecasting algorithm can formulate this kind of historical data and make a model so we can have a prediction for the next day or for the next hour or for the next 5 minutes. because the electricity market actually can be divided into three: for the day-ahead market, intraday market, and real-time market. Day-ahead market will be the next 24 hours, and within the hours in this day, we can have an intraday market, and within a minutes or 5 minutes in these hours, we can have a real-time market. And this market actually is about the energy market, reserve capacity market, and the power market that need to be supplied to the demand. And a smart automated controller makes an optimal decision based on the price signals and more static consumers' preference in this market architecture. So that's why we need the forecasting algorithm actually to have a good decision for the next day or for the next period like that. And forecasting algorithm is not only, like I said, is an energy, right? And energy have many type of form, many types, have many types. The energy can be seen from the load demand, or maybe from the power generation from the renewable energy, like PV power generations, and also wind power generations, like that. Because till now, the most renewable energy used for a power system grid reinforcement is PV power and wind power. And the forecasting algorithm is necessary to support the smart grid. And that's why we can have a study about the forecasting algorithm, how we deal with the model, how can we try to replicate the actual load conditions in our model. So we can have a good prediction when we put some inputs into the prediction model. Okay, so this is just an example. This is for load forecasting, and this is for PV power forecasting. And again, because we talk about the renewable energy, we know that the energy, energy resulted from a renewable energy will be very variable, right? I mean, there's so much variations in the renewable energy generation. That's why the forecasting algorithm can be broadened, not only the deterministic forecasting, but also a probabilistic forecasting. Why we need the probabilistic forecasting? Because we will study about the variation, the upper bound and the lower bound that can be modeled with a prediction interval like this, or maybe just a probabilistic model that can represent the variation. Because if we want to have a good decisions, we need to embrace the variation in renewable energy generations. That's why intermittency should be modeled properly. Okay, and again, another key factors of smart grid will be the sensors, because we want to monitor what's happening in the power system. And the sensors is very broad, right? I mean, the application of sensors is not only in power system, but also can be attached to another application based on our goal as a designer. And this is just the example. The Alliance for Internet of Things innovations in the system, health system. So they will put the sensors the input will be the data from the private community and also the public, like a hospital or any public government like that. And from these sectors, we can generate the data. We can have data. And by having the IoT platform, we can manage this data and we can get some analysis, we can get some decision about the data that we get here. And what is the decision look like? Okay, the decisions after we gather all information and all data is a service. So we can have many service according to the data that we get here. And by that, we can put this service to improve the quality of living in the individuals or organizations. And by that, a circular economy will be achieved because we can provide a service, according to what they need. And it can improve the quality of the subject. Okay. And again, because we need to have an analysis, we need to have a management of the data, we need to generate a decisions. That's why we need machine learning algorithm. Because this kind of algorithm can help us to have a data analysis, can help us to have an extractions, the interpretations, and also the accuracy improvement. I mean, like the previous example, we can build a service based on the data that we have, and by having the machine learning, we can easily do it. We can be helped. Okay. And yeah, the machine learning algorithm is not only about the deterministic, but also can have a probabilistic approach actually. So by having this machine learning algorithm, we can model the intermittency. We can model the variations, just like that. And another idea of smart grid is system integrations. System integration is mean like not only in a specific sectors like the technology of renewable energy or the industry, but how can we integrate all of these aspects? Because this should be done because we want to have a sustainable improvement, right? So it is not depend on one aspect, but it should be depends on every aspect. And how do we correlate it? It depends on us. How can we try to find a solutions to achieve the goal, maybe the power to mobility, power to gas, or power to heat, by incorporate each of these aspects. Okay. And right now, the idea is become these two. We staying big or getting smaller. Because if we want to achieve the sustainable development, the expected structural change in the energy system should be done. Not only from a bulk power plant to the distribution, but right now it will be two ways of communication, or maybe more ways of communication, which is the decentralized power system. It will be ignoring the boundaries and also can be supplied and also can be achieved from the distribution side. Okay. I hope till now you still can get what I want to deliver to you. So by having smart grid, we try to achieve the sustainable development goals in which everyone should have the same prosperity and everyone should have the same energy access and everyone need to have a same the same goals like that. And again, the stress is how to achieve a balance between economic, environment, and also what is the one aspect of renewable energy? Oh, the economic, environment, and the social. That's the aim. So if we again talk about the role of academia, what is the role of the academia? Do we just do as a student and also as a lecturer, I have experienced both of them. So the big question to all of us is, what are we going to do after we graduate? Is it just like this picture that we throw all the responsibility, we throw all this kind of hecticness, and then we do nothing, right? It should be more than that. After we graduate, we need to have a good solution for our living. And what I want to talk to you is like, in academic life, let's try to improve ourselves, become better and better. So when we face the real challenge, we can adapt and find a solution for that, right? And how do we do it? So the role of academia, the curriculum, the learning, the knowledge gain, it should has the ability to view the problem solutions in their entirety. I mean the holistic approach, not for a single problem, but how can a problem that will be resulted from this problem can also be solved. So we need to think a bigger picture, not only a small one. And next one is creativity and willingness to innovate and question the traditional approach. Don't try to be, in so much comfort, right? We need to think how to break the traditional approach. That's why we need to always improve our creativity and willingness to innovate and question all the traditional approaches. And the next one is the problem-solving ability. The academia, the lecturers and students have to have an ability to solve a problem, to choose what technology is suitable for this kind of problems. Just like a traveler like here. This traveler is easy to choose what destination she needs to go, right? Because of what? She has many options here. So that's why in the school, all of us need to equip the students with many ability, right? It is actually just supporting materials. So when the students face the real problem, the students can choose what is the best option for this kind of problems. And next is we need to have an ability to apply an interdisciplinary and multidisciplinary approach, in which we're not talking about a single solution, but we need to talk about a single solutive system, right? How can we incorporate all the problems and then formulate solutions? Maybe we will have like not only a single problem, we have maybe a problem in resources, a problem in waste, a problem in energy. But how can we solve it? We need to try a smart ways. Okay? Maybe in the workforce, maybe in the supply chain to make a less waste, and maybe in the manufacturing. Because all we face is resources or waste or energy, but not in a very high quality like that. So how do we deal with a good approach by having this less resources? And again, the academic life should try to build a approach for having a social competencies and the ability to operate in teams. Because of what? We cannot live alone, right? So we need a social competencies and ability to operate in a teams. Because what we need to aim and what we need to finish is a big goals, not only, the implementation or the success rate will be depend on the team. Okay, so now if we talk about the energy optimism amid economic crisis, like right now, all of us, all part of the world have been subjected in a very chronic disease, right? The COVID-19, and all of us are suffering. But how can we stay positive and can adapt with this kind of situations? We need to think that from the academic aspect, when we think about the skills that we gain in the academic life and also all the resources that we have, we need to think globally, but we need to act locally. Why I said so? Because we cannot, right now there's a restriction in traveling, right? What we can do is just a local resources. That's why, even though we have all the knowledge, we need to try to apply that in our local. And this act can be improved by having the maintenance system like this. This is a plan, do, check, and act, right? So whatever you had discomfort or whenever you have any problems, just plan what is the solution for that. And maybe the first solution will not have a successive movement, right? Before we do it. That's why a plan needs to be done and then evaluate and then adjust. And then we can have a better solutions for our problem. So to have a right approach, we cannot see everything separately, but we need to have an integration of all of this. So my message is, let's try to incorporate all of our knowledge and action together with the evaluation so we can have a good solution. Okay, so this is just a problem, problem formulation. Not a problem formulation, just a case study for how can we apply that kind of think globally, act locally, and then do, plan, do, act like that. Let's see from this. And as we know, there's a COVID-19 pandemic, and it has increased the energy usage in our daily life, because when we before the COVID-19 we used to work at office, right? So we don't really use energy when we in our working hours. But now because of COVID, all of us need to work from home. That's why the electricity usage in a home or in the distribution side is increased. And this is the curve of the electricity consumptions, and we can see the distinct increment, abundant amount of energy use. And it is breakdown from a energy supplier. The energy is supported by the coal or renewables or the gas. So this is the specific energy that we use in the electricity usage. And when we see this trend, wow, the electricity is increased. What should we do? Right? So we need to think about the solution. How can we deal with this kind of energy surpassing? The increase in electricity usage. One of simple idea can be, maybe we can make a monitoring device that has an alarm. So when the bill is reaching a certain limit, this alarm should be turned on. So the users in a home can have notifications. It can be like that, right? The idea can be as simple as that. Just have this kind of idea can solve a problem. But we need to do it first and then we evaluate, right? Will it be the solution? Will it be a solution for this energy usage problem? Maybe yes, maybe not. Because maybe yes, it can reduce the electricity consumption, but will it be sustainable? This kind of thinking need to be applied. Will it be sustainable for the next day, next month, or next year? Let's see. Because of there's a energy usage increase, right? So if we just have alarm like that, it still will not solve the problem because we still need an energy. That's why another idea should be we need to provide an energy. So a smart home system equipped with a rooftop solar cell can be a solution. Because by this, we don't need to worry about the electricity bill because we already generate our own electricity. Is it true? I guess so, right? But then, again, if we take a look on the sustainable development goal, it is not talking about us, not talking about a single person, but it is talking about everyone should have the same access to energy. Everyone need to be rich like that. Everyone need to have good conditions. Will it be a solution for that? I guess not, because this can be beneficial only for people inside the house. That's why we can broaden our idea into like this. Not only talk about a single house, but we can talk about the community. How can we make a hybrid renewable energy microgrid system to supply a community, right? And then when the energy have been fulfilled like that, what is it already finished? Is it already the answer for all of that? Maybe another problem is arise in which we are hungry like that. They have energy, but they don't have natural resources to fulfill the hunger. So that's why we can come to an idea, how can we manage an independent resources management like that? By having maybe a smart farm. So by having this kind of farm inside a community, this community will be accessible to an energy, to a food, and to an access. So maybe it will be a better idea, right? I mean, a better solution from our early problem. And again, by having that, we also need to think about the circular economy, which is not only about the recycling. So we can have a supply and demand, but we can supply the necessity of the demand by our own resources. And that's I think this kind of idea should be applied for the first problem, which is the energy usage problem. And in the electrical engineering point of view, actually, we have a problem about the renewable energy integration, right? If we want to apply this in Indonesia, I mean, actually, the basic idea of the power system will be how can the generation supply the demand? It should be the generation should 100% or maybe 200% fulfill the demand. But when we want to have a renewable energy integration to the system, the renewable energy itself have an uncertain power reserve. Yeah. So if we want to talk about how can we manage the energy from the wind power and also the PV power to the power system, or maybe when we want to integrate the smart electric vehicle here with a battery charging station, the problem will be the uncertainty, the variations, or the intermittency of this kind of resources. How can I think it will be, this will have an effect to the power systems. And by having the renewable energy integration, it can cause an overload to the power system, because this power system, as we know, smart grid is just an old power system, but equipped with a control and monitor system. So if we want to put the renewable energy inside, will the power system ready for that? It depends. It depends on the planning. It depends on the planning of this power system, because the planning will affect the capacity of each feeder, the capacity of the transmission lines, the distribution lines, like that. As long as the penetration of renewable energy is still low, I think this power system is okay. I mean, with the renewable energy integration. But in Indonesia, the problem is not only about the technical aspect of the renewable energy integration, but our problem is we have more generation than the demand. So how can we solve it? Yeah.
Excuse me, Miss Happy.
Yeah.
5 minutes again.
Okay, thank you. This will be my last. Thank you, Mr. Haris, for the reminder. Okay, that's for the renewable energy integration. But again, let's have a breakthrough solution. I mean, the critical thinking. This is just another simple example. I like to eat, right? I like to eat hot pot. But as we know, hot pot needs a stove. Hot pot needs something to boil the water, and then we can enjoy the hot pot. But when we have no stove, when we don't have any stove or fire, what should we do? What should we do to still eat hot pot? with the help of science, actually, with the help of the skills in academic life, we can have a solution for this. How to do it? I don't know. Maybe some of you have learned about the chemical reactions, exothermic or endothermic. Actually, by having these exothermic reactions, we can have a boiling procedure. We can make a heat without a stove, without a fire. And it is already done by some products. They have a self-heating hot pot just by applying this kind of exothermic reactions. And it is make me overwhelmed because, wow, it is so simple, but it is applied and it solves a problem of eating the hot pot. And yeah, I think from this figure, I think I just want to tell you an idea, even though we need to think further, we need to think further than only today, but on maybe the next year, next month, like that. The idea can be, can be from a very simple idea, but how can we apply that? That's the question. Okay. Okay, so this is the end of my talk. Actually, I want to deliver an idea for you from the academic life to manage a resource. We need to have a contribution of research. We need to think an innovation. What is the innovation? So we can have a contributions for the energy management. And then this kind of innovation actually can be done by having a dedication to develop a smart, innovative, and competitive society in facing the challenge of global competitions. And also the development of curriculum that supports the revolution in energy is very necessary. That's why there's a freedom to learn scheme from the government of Indonesia. And by this kind of scheme, the role of academics in managing and developing national energy can be done. Even though it's not easy, but let's try our best together. Okay, that's all my presentation for today. I hope you guys can get what I want to deliver, and it's all depend on our hand. How can we make a good society and prosperity for all? Thank you. Okay, so I will return my room to Mr. Moderator, Mr. Haris.
Yes, thank you for Dr. Happy Aprilia. Very good, very interesting topic to discuss. The image display is as very interesting too. For the first session, I am going to choose 3 questions. The first question, why is Indonesia currently have difficult implementing renewable energy? Until when Indonesia depend on using fossil energy?
Okay, so maybe I will try to answer now. Thank you for the question. Yeah, the difficulties of having the renewable energy in Indonesia is not only about the technology, because all of us has learned about that, but it's more about the policy from the government. We know that there's already a fit-in tariff from the government, right? But maybe maybe we don't really think about the benefit, but we think about the how to say, the energy support, not only about the money benefit like that. So maybe the students or the lecturer can try to have a community service regarding the application of renewable energy in a local scale. I think that's my answer. I hope it answered the question.
Yes, thank you. Maybe we can next session, Bu Happy Aprilia.
Okay.
We will continue to the next session with the second speakers, Dr. Hao Wang, with the title Application of Big Data as an Energy Electrician toward Industrial Independent and National Energy Security. Time is yours.
Can you see the screen?
Yes.
Great. Right. I might have a slightly different title for my talk because I did not really, capture all the stuff, especially related to like national energy security. But I guess it's fine here from like a perspective of the more technical perspective. I guess all the audience are like from the some technical background in electrical engineering. So I guess it might be good to talk about more technical stuff. But I certainly will cover some of the development of the renewable energy. All right. Okay. So let me start.
Okay.
So yeah. So I have like around an hour, right? So I probably keep it within like 50 and 55 minutes. Okay. Yeah, I'm from Monash University. Here you can see just a little bit brief introduction to our university before we jump into the technical stuff. So we have, right now, so our university is one of the so-called Australia's group of 8. So there are 8 universities in this group as the leading universities in Australia. And due to, according to the latest rankings, we ranked, you can see here, 55 in the QS ranking, 48 in the US News ranking. So it's pretty good, and we are still growing. So related to energy, so our university has a commitment to zero, so-called net zero carbon emission by 2030, which is approaching just in 10 years. So we want to like have 100% renewable future, at least started from our campus. So we can see here, we have like an implementation plan to increase our energy efficiency, to electrify our campus, and to have both on-site and off-site renewables, and to have the management, like building a microgrid by installing a lot of different things like battery storage, like renewable on the solar panels, and then to achieve the goal. So we are building we call it Monash Smart Energy City by installing a lot of so-called distributed energy resources, so such as solar rooftop solar panels and storage, electric vehicle charging station, chargers, and management of buildings, smart buildings to achieve the goal. And we will develop our own control and management algorithms to manage all those DERs. So this is a huge opportunity. Also to the outside grid, because we have quite a large capacity in terms of the generation and also the demand, about maybe 30 megawatt. So we can also provide service to the grid. So, which is a kind of very good thing, not only for us, the campus, but also for the local electricity grid. So building this microgrid is gonna enable us with a lot of different functions, and but basically through physically the integration of distributed energy resources, a lot of flexible loads from our dormitories, and we have a huge battery system. We have also like other solars for sure, and smart management or intelligent management or active management, or all those DERs, and to management them like in the way to minimize our carbon dioxide emission, and also minimize our operating cost, and sometimes providing support to the grid and to also the Australia national electricity market. So this is from our university's perspective. So in terms of the details, you can see here we have at least already we have megawatt capacity solar. We have a megawatt hour capacity of battery. Two kinds of batteries: one flow battery, the other is the typical battery we can see, and also EV charging stations. So combined with all those different resources, we're investing huge amount of money into this to achieve our commitment to a net zero future by 2030, which is a very ambitious plan among all the universities, not only in Australia, but also even compared to those and in the US or other countries. So we are leading the way. So after just a brief introduction to Monash and its commitment to the energy, sustainable energy, let's start with so-called energy system. So we have like, well, I think everyone here knows that we have, well, we certainly are energy users, electricity users, and we know that the electricity is generated from somewhere, from power plants, and certainly now we have more renewables. We have large wind farms and solar farms, and all those generated electricity are going to go through so-called this power transmission and distribution network, operated by different levels of operators at the transmission level and also at the distribution level, and all that where electricity gonna reach us, right, and to the end users, like different industrial users, commercial users, and residential users like us. But we are, I think, we see that there's a huge change in the system, a kind of a transformation from this traditional power system to so-called, a lot of term for that, maybe smart grid and maybe intelligent power network, the different terms used in different countries. But so the common feature here we can see is we have a lot of new infrastructure built and not a lot of new devices integrated into the system, such as from the generation side, we have renewable energy, all kinds of different renewable energies. And actually at both sides, at the generation side, and also just aside of the some end users. So those are very small scale energy resources. Like typical example is just the rooftop solar. And we have also batteries or storages. So we have very large one that we have for so-called maybe I think in the US, in the San Diego, we have like 250 megawatt hour capacity for any storage farm, which is huge. And we also have small batteries, not our smartphone, but like a Tesla power product. So around 11 kilowatt hour that is used, deployed at household, and can support some charge and discharge. When there's a blackout, you can still use the electricity from the battery. And we have also smart meters, or sometimes we call it digital meters. So you can record a lot of information, including the usage of electricity consumption, sometimes both active power and reactive power. So you can also communicate with some kind of local communication center or access point that to transmit the data, the smart meter readings. such that the utility would have our electricity data to better manage the system and also to provide better services to the users. So all those devices adding to the system does not just simply say they can work. So they have well, they need to like be well managed and to work with others and to also work with the old system. But we are by not only upgrading the hardware but also the software, which actually is a paradigm shift from the traditional, more like passive or centralized operation to a more proactive and more human in the loop and the decentralized system. So later I'm gonna try to introduce what do all these terms mean, especially if you choose to kind of work in these areas. And just a little background on the global trend. So here's the estimation of the global energy consumption. Certainly, certainly for the global one that we can see, even in this case, renewable grows very fast. And we are shutting down a lot of oil and coal-fired power plants. That's also the global trend. In the US is the case, and especially for the next year, in the Biden administration, that would be a huge push forward of this renewable energy and to tackle this climate change issues. So that is a big call for us, climate change, and what will be the efficient way to reduce the emission, and will be a better way to really manage, right, or even stop, right, the global kind of climate crisis and warming, right? So, and reduce the carbon dioxide emission. So, which is certainly a huge challenge, and sometimes we are not even making progress in the past years. But we can certainly, this is a trend. But if you look into different countries, then the figure will be different. So, for example, in countries like the US and some European countries, even including, I think, Australia, that the energy consumption is not growing actually. The growing is mainly from the developing countries and regions, because there's still, well, right now, people still lack access to the reliable power supply. And certainly they need get access, right, to have like a more reliable grid and to have access to electricity, and that's going to improve their the living quality by a lot, and that's also part of the goal of the UN's Sustainable Development Goal, right? So different countries don't have different like the growth in this electricity usage, but nevertheless, the mix of the energy or the portfolio of the energy sources, right, look all pretty much the same. And we are using much less and less oil and coal. Sometimes gas is still, we need to rely on that because we need gas to sometimes for heating, other for generating electricity is to have those fast responsive gas turbines, which works perfectly to meet the peak demand. And more like for the base demand, we are trying to supply the electricity from nuclear, hydro, and mostly from renewables, all kinds of different renewables. But certainly, you know that renewable energy generation is quite intermittent and stochastic, quite random. So it's not like any other generators you can actually control. You can really not dispatch, right, renewables, because if there's no kind of sunshine there, you don't have solar generation, and where you get electricity supply from solar, right? So it's there's quite a lot of uncertainties in those renewable generations. So a promising solution to that, right, people are now trying to develop in the technology of the energy storage or different kinds of batteries. not necessarily batteries, but all kinds of different energy storage technologies to store and to harvest, right? So renewables when you don't use them, solar, wind, and even other sources, and then you can use them when you need it and where there's not enough supply from the renewables. So storage certainly is a actually so-called game-changing technology in the power industry, but still very expensive. If you look at the U.S. right now, this is by 2017, the accumulative energy storage capacity is just over like 1,000 megawatt-hour. So compare this figure, right, the number to the wholesale market or the total capacity in the U.S. This is a very tiny and just a number that really cannot make any change. But certainly it's developing, and especially for those states in the U.S. like California and Hawaii, because these two states have higher capacity of generation from renewables, and it makes more sense for those two states to have higher capacity of energy storage to store renewable at both levels, at the grid level and also at the users level. And certainly the research around this energy storage is still underdeveloped, from its material to its product, right, and to its performance and to its applications. So there's a huge amount of work need to be done in this area, and to really enable very efficient, low cost, high performance energy storage system to support our current energy or so-called power system or power grid. And certainly the other researchers are more like optimistic. And here's a researcher from Stanford University, Professor Mark Jacobson. And his research, right, tried to identify like a roadmap for most countries, I guess maybe most countries in the world, to have 100% renewable energy, which is extremely ambitious. And certainly our arguments around this issue, whether we can achieve 100% renewable or not, we don't know. And a lot of different researchers from different backgrounds argue that probably it's not feasible. But never mind, we have this, they provide the research outputs and to calculate, right, so-called the potential, the possibility that around 39 countries can be powered by renewable, right, at 100% from all kinds of different resources, mainly from three actually, from solar, residential solar plant, that is a very large one, probably in the desert, in like Nevada in the US, or Texas in the US. And also here's a so-called, so this is another type of solar power plants. It's not generating electricity directly, it's still to use the heat, right, to generate power, use turbines. But all kinds of different technologies from the solar, which is the big portion of the mix of the renewables, can be used to achieve the 100% renewable goal. And the other from the offshore and onshore wind, which is also remarkable. And the other from like a wave when you have, right, aside the sea and also other type of different renewable energy sources. And this can actually help us to reduce 99% of our carbon dioxide emission which is huge, and to basically solve the climate change issue. But certainly it's a long way to go, and here is just like a projection, or not a projection, it's just a feasibility study, and even sometimes people argue that it's not feasible. But we are pushing this, we are moving toward this goal by developing, right, a lot of different technologies from both hardware and software, and to certainly there's a role of the industry, right, the other investors, right, and also the government to have the right policy and all sort of other support to achieve the goal. But as engineers, right, I suppose most of us here are electrical engineers and or computer scientists or civil engineers, but we are engineers or scientists. So we kind of focus on the technical side, try to push the technology advancement, right, to address, to make this, right, real, and by our research, right, and education. So yeah, I think we got quite some background here. So here I try to summarize some of the research from my own, and try to give you like a idea for some of the state of the art and in the research community. So I call it idea. So you probably heard a lot of idea today from from other speakers, especially Happy. Happy is a good friend, and so we here. So I try to talk about three different parts from generation, so-called integration of renewable energy. So try to integrate more renewable energy, how we can do that. And also from the demand side, so how we can try to kind of engage users and try to understand better, because we have familiar data right now, we can analyze consumers' behavior and try to understand them better and try to let them kind of be part of the system operation. And also when the first part supply and the second part demand, right, do not match, so we still have energy storage. So we can have batteries in the system at both grid level and at the user side, on the user side, to help mitigate the mismatch. So it's kind of a full dimension solution, right, around this say energy system planning and operation. And the topic today, I try to focus on more data. And you can see that we have data and we try to use the data to get an idea. And we get the idea, we advance all different three parts: generation, supply, right, and demand or load, and energy storage in the middle. Try to build a more smart, like smarter, more reliable, and sometimes even affordable grid, and mostly from the renewable. That certainly fit into the top topic today, that to secure, which is certainly related to national energy security, to have more renewable from local resources and to operate them in a way that it's smarter, right? It's more reliable, and also provide affordable electricity to users. That also is a big issue. You cannot have higher, electricity rates, right? And while having a very stable, kind of society, you have an energy crisis in that case. So certainly all of the research findings here, or the efforts here, are certainly related to our national energy security in any countries, right? So here I try to focus on more technical part, how we develop all those different methodologies, right? So And eventually, we can have a better system. We can help to build a more secure energy system. So let me just start from the first part. So the first part, I can see that I try to have like a more concise figure here from the generation to demand, and in the middle is a grid, and also we have energy storage is actually from both sides, but I put it here, which is try to say the storage is try to well, actually both sides from with the grid and with the demand. So let's just to look at the figure here to see what's the problem, right? If we have renewable. So the figure here we see here's this is a very small scale, maybe just a one kind of small from 1 meter, for example, from 1 smart meter. Maybe this is a lot. Well, one user, say let's say one user's load. So certainly increases when people get up and use a lot of appliances and then go to sleep, and there's a kind of base load. So this is one of the typical load. And sometimes you can see other typical load that has more kind of like a peak, for example, at nighttime or evening time, that is more residential pattern, right? So, but anyway, that is, we have different patterns for load. But if you look at the generation, here's the generation from the wind. And if you have solar, that's fine. You have something similar. But if you look at the night time, you have no solar to supply that. And the wind is even worse. That you sometimes certainly depend on where you are and the wind speed, right, over time. And sometimes this is from the real case. And here, wind cannot support the load. Solar can, but solar cannot perfectly match or meet all the demand, right? So we always have the issue when we talk about renewables. Renewable don't go with the load, but we need to have the perfect balance between the load and the supply from renewable, whatever resources you have, to have a perfect balance in real time, which is very challenging for the power and the energy system. So we have this mismatch. And is there any way to to improve or increase the utilization of renewable energies? So based on the data, here we can see that in different locations. So here's the solar energy typical patterns and other two places from the wind power. So very interestingly, you can see that from the two figures, they are very, say, complementary, which means that in daytime you have renewable, at nighttime you have wind. So in other words, you have supply right for the whole day. If you have both, that's complementary, right? But sometimes it's not that complementary, it's more like substitutive. For example, you look at figure 1 and 3. And you also have more generation at say at daytime, right, for the third one. But the generation capacity, if you look at the scale here, is only 0.5, here's 1. So which certainly means you have more generation from the wind per installation, per capacity installation, right? So in this case, if you can use the solar instead of wind in this location, certainly it's better. So we have those kind of different correlations between different resources, right, across different locations. And that actually, from the real data, and we can, that actually motivates us or generates some idea, right, to look at a more interactive energy use or planning. For example, we can have like so-called energy internet, or sometimes people call it transactive energy or energy trading, whatever. But certainly energy internet is a kind of larger scope and covers a lot of different topics. But let's say in this case, you have grid and you have different, say, microgrids. And what you can do is, traditionally, you look at one and you operate that. But what you can do here, based on the previous observation from the real data, you can mix, right, different microgrids, or at least let them interact with each other. Say, in one place you have more generation, in another place you probably don't have that. In this case, the other location can buy electricity from others to try to use that excessive generation that it will not be used in locally. So they are actually interconnected. Try to utilize the resources and to leverage their diversity in the generation or even the demand. So this microgrid, just zooming a little bit into one microgrid, you can see you have different loads, you have generations. Usually, sometimes you have other, like the fossil fuel generators, but let's say focus on we have more renewable generators, right? And how we can design a system, right, for those different microgrids to talk to each other and to trade energy to improve the utilization of renewable energy, right? So certainly it's challenging to do that, because microgrid, if you think of like the way that your campus has a microgrid, other hospital, other commercial buildings, they have a microgrid, but you are not, so you don't belong to, say, one, say, unit or entity, right, a group. So you are independent, others are also independent, but how this different independent, even sometimes selfish is not a bad concept in economics, right? So it just, you care about your own interest, your own cost, right? How can those different independent and selfish microgrids work together? So definitely here is about economics, how you can provide incentive to all those different microgrids to work together. You need like a very good mechanism to make it work. And certainly people don't want to give their own data to others, right? So there are some privacy concerns. So to really tackle all those, to remove, for example, all those barriers, right, we need to develop like a solution. So here is our solution. We design an incentive mechanism to ensure that everyone is happy to interact with others, to trade energy. And we also implement a distributed algorithm to kind of reflect or to implement this mechanism to make it work from a kind of a scientist or engineer's perspective, not not a kind of economist. So system model here, we have microgrids interconnected together, and inside the microgrid, they have different renewable energies, and they have storage and to meet and also have different loads, users, and there's operator running this microgrid. For all this microgrid, they have independent operators. So I try to skip the mathematics, but the key idea here is to, if you want to provide incentive to others, you need to provide a better offer, right? Better than outside choice, right? If you have a choice, saying going to a university, a very good one, if other school want to recruit you, right, they need to give you a better offer. That's incentive. Different, can be monetary and can be other commitment, all kinds of different incentive to you to take that offer, right? So basically the idea here for us is the same, that every microgrid has its own outside choice to operate their microgrid. There's a certain cost, but we try to let them interact with others and to trade. And there's a certain associated trading payment. It can be income, it can be like payment to others. But the total cost won't be greater than the outside choice. Basically meaning, if you interact with others, I guarantee you can reduce your cost. So that provides incentive to the migrant, to everyone. So we put this into our optimization problem to make sure that this is providing incentive to others. And solving this problem, we cannot use so-called any solver to get all the information from all those migrants and to solve it. That's the typical way of solving an optimization problem. As I said, there's a huge concern around this privacy, and people don't want to reveal their private data to anyone, even not to the grid. So their inside operation, right, internal operation, will not be revealed to anyone. So in that sense, we need to develop a so-called decentralized or distributed decision-making framework. So we have the market rules or incentive mechanisms, right, developed before, but how we can implement that to make it a reality, we need to have like a automatic algorithm, right, run by all those migrants independently. And then they output some kind of information to exchange with others. So this is essentially how this distributed algorithm can do. So we have a virtual clearinghouse, basically is to get the information from all those migrants of their own trading decisions. And cleared, it's just like a stock market, but it's not actually the real price or real market. So there's no kind of a clearinghouse actually, so that's why it is virtual. It's just a computing module. It can be anything, right? You can set up like an IoT, Internet of Things devices to communicate with others, to get information, and to add it up and send it back to all the others. Then people know that the market is not settled, it's still a mismatch, or even more, sometimes more supply, sometimes more demand, and people can adjust their own, like the bids into the system to interact with others. And eventually this algorithm, through these iterations, right, among the migrant operators, it's gonna converge. And we can prove that it converges to the optimal, say, trading decision and minimize the total, so sometimes so-called social cost. So it worked, and it implemented the incentive mechanism using this algorithm, which is amazing, right? So this is like the contribution here to enable migrants to interact and to address their concerns around privacy or incentive. So some numerical studies can show that these three migrants, they trade energy, sometimes positive and sometimes negative, basically meaning sell or buy. So basically means they interact. Sometimes you buy, sometimes you sell. All depends on, right, your own like renewable supply and your own demand, right? If you don't have enough supply, you want to buy from others to supply to meet your demand. Sometimes you have more generation from the renewable, you want to sell to others. So actually forming a local kind of platform that this power flow can from here and there, do not need to go above the to say the distribution to the grid, right? So you can do it locally using the existing infrastructure. But certainly, we need to have those sometimes so-called bi-directional inverters and to enable this two-way, right, power flow. But that's certainly another technical issue to address. And we can see certainly everyone is happy because the total cost is reduced, and also individual cost can be reduced by 36%, which is good. And in addition to this, say planning, operation of this trading, we can also do a planning in a cooperative way, also based on the realistic data, as I said, different places, different potential, and they can forming like a coalition, right, to invest, to do the planning together, and to fully utilize the renewable resources in those places with the highest potential. So again, just to skip the math, they can again forming coalition or group, talking to each other, saying that we can give you money, right? Some money, and we can put into like a pool and use that money to invest in different locations. But it's kind of a joint venture that we can all use that electricity invested, the capacity of renewable invested, and then split the bill, right, based on how you benefit from this program, right, from this so-called cooperation or the cooperative planning. So we do a numerical study here. We have a framework to do this, and here's the numerical result. So this is an investment, for example, for those 4 locations, and for the first one, there's no investment. That is because this is a location close to the city, and due to limited, like the say the land, right, and also the high price, right, then probably you don't want to invest there because it costs too much, and there's not good return, right? And in location 2, there's a good example that it does not have good wind, so the investment goes to more to the or to the solar at a certain point, and other locations has good wind and they can do the wind power installation. So actually, the 4 locations right? They talk to each other to get a best plan to invest for the interest of the whole group, not for individual. So in this way, they can fully enjoy or utilize, right, the renewable energy from those 4 locations. So if 1 and 2 they don't talk to others and don't right form this coalition, then there's they need to invest, right, huge into the locally, and that is just a waste of money. But in this case, they can talk to each other to form cooperative group, do the cooperative planning, and then split their bill. And we can see that if they don't cooperate, this is a huge cost for the first place. But if it cooperates, the cost reduces significantly. Actually, everyone are happy because they all reduce their cost. And then later, based on the cost reduction, people are going to split the bill. It's just you and your friends, right, went to a restaurant and then probably just an even split. But in this case, it's a split based on the benefit you get. So you can, in this case, location 1 benefits the most from this planning, and you're gonna pay the most. But still, after split the investment cost, everyone still is happy with this outcome because everyone still reduced this cost. So that's another example to show that you have like diverse renewable energy. You want to kind of work together to figure out what is the best for us all. And then we have mechanisms and algorithms to help you manage that. And this certainly increased the renewable energy, the utilization. And also it's the best for the society and for the country, because we are identifying, right, the best place to invest. Even there's a kind of conflict of interest, but we try to make them cooperate. So this is from more like economic perspective to improve the renewable energy utilization. And after we're talking about this generation, sometimes generation we cannot really get a fully 100% dispatchable generation, right? So we still have a mismatch. So what we can do, right? We still, in this case, we ask the demand side of the users to cooperate. So if you have a peak, for example, here from the load and cannot be met by the supply, right? So the supply certainly has a kind of shortage here, cannot meet the demand here, a peak demand. So in this case, the solution is ask demand to reduce that. Or sometimes you can curtail that, but in this case, we don't do that. It would just ask you to cooperate. Someone did that, and we can have a kind of lower demand and which is no greater than the supply. So if we want to meet the supply, basically the old way, well, even the current solution is to invest more, right? To expand our network, to expand our generation capacity, and have more standby or sometimes gas generators to meet the demand. But that's costly. That costs you a lot of resources, right? So just to give you an idea, that we want the users to participate as well. And certainly, if we don't know users how they consume, we cannot do this. But thanks to the ICT, right, advancement, that we have more digital meters or smart meters. So smart meters can here monitor the consumption, right, of all the household, right, activities and usage, and then send this information to the utility or your or broker, right, and then to send you a bill. But based on the data, we can know a lot, right, of the users' energy consumption behavior. And if you know the behavior, and then you can design certain programs to engage the users. Right? Without knowing that, you cannot achieve so-called either demand side management or demand response, or to engage users. That's no way, right? So here, the smart meter collect the meters, right, collect the data from the users, which is invaluable. So right now we have, so based on the data, for example, what we can do, right? So previous studies have already looked at this problem, say, based on the data, you can try to figure out what is, what the user's load, right, looks like, or what are the users' load patterns. So by patterns, basically, it's like you have like a load curve every day, and they try to figure out what are the typical or the most representative load curves from this user, and that is your pattern, just to put it simply. But sometimes we, I think, and maybe more than half of the meters are replaced by the smart meters, but in a lot of different places, there's still not say enough digital meters to collect data. So here we figured out a way that can we do here some like a more interdisciplinary approach. Say, can we understand users' behavior by looking at their background, their socioeconomic data, or their demographics, such as education, income, and so this is actually very straightforward. For example, some study showed in the past that compare with kind of like families with kids, right, and other school dormitory like you guys, and the load pattern are certainly different. For the household with kids, they have more kind of a routine activity, and go to work, send right kids to school, and cook. So everything looked like the same every day, and sleep early usually, get up early and usually, right? So, but compare that with say the electricity consumption, those curves of like a university dormitory, or that would be huge different, right? You probably observe peak at night, late night, overnight. So that's the behavior difference. So based on the realistic data in Texas of the US, around maybe 300 households, we can cluster the data to figure out saying this is a typical load we have. So this is very typical, like evening peak and night peak for a household, and then go to sleep and go to work at daytime. So that's very flat in the daytime. And also typical here. Sometimes not that typical is you have those late night curve, but with a little bit lower like probability. And sometimes you have very flat load over a day that probably is people not at home. So there's all different patterns. Behind that is there's some kind of implication, right? Implication that how people behave. And this is based on realistic data. And what we try to do is say, can we get the idea saying, based on all those socioeconomic information, we can predict that? The answer is yes. We can use a deep neural network, use deep learning to learn their relationship, right? And then the result shows that it's pretty accurate compared with the ground truth. So this is the research using deep learning and data, right, to predict and to learn users' behavior. And here's a more kind of fundamental work that if you have limited data, you don't have the historical data to do the training for a large neural network, right? So you only have, each time you get one data point, which is very limited. Can you still learn the user's behavior? The answer is yes, we can do an online learning algorithm. So I skip the math, which can be quite scary, but look at the result. We compare an online learning case basically is that I send a signal to users and the user respond. I each time observe one data point. And in other cases, I know precisely there's no uncertainty here. I know how people are going to behave. Then I can calculate so-called kind of offline solution, knowing everything. So this is a kind of benchmark, certainly is achieve the lowest cost because you know everything, you're going to be the best. But if you want to learn from the users with limited data, which is extremely challenging, can we learn it? Sometimes you cannot, you learn nothing because it's not enough data there. But here we see actually it worked. So the gap between these two decay very fast, right, by time. And around maybe 50 or 60, there's no gap. So no gap basically means after, right, this time, right, 50, 60 time slots, these two are basically the same. So meaning that we learn the user's behavior and achieve the best, right, compared with the benchmark. So this is a little bit more fundamental study saying that in the middle there are some mismatch, but later matches very well with the offline solution. The offline solution is that you know everything. So this is also pretty amazing that even with limited data, right, you still can use machine learning to learn users from users' limited data and to learn their behavior. And based on behavior, you can still do a very good management or control of the system. So here I show you using deep learning or online learning, those different machine learning tools to work on the data of users and to understand their behavior, which is doable. And actually, and the result is quite good. And actually, a lot of work in this area, and so you can keep an eye on that. And yeah, because we have more data right now from the majors. Yeah, last, just to briefly talk about, say, energy storage. So if we have the generation and demand that does not match very well in real time, we have storage to do it. And in the US, certainly there's an energy price reflecting the demand and supply mismatch. But it doesn't matter. You can have like the mismatch as a signal here. It's the same, but the price is just a reflection of the mismatch. And actually, it's very unpredictable. So here's today's mismatch reflected by the price. And how about tomorrow? So people are gonna make a guess that probably the same, but actually the realization is something much higher, much volatile. But you never know how you can predict the price. Do you know the price of the stock tomorrow, which is extremely challenging, though there are some work there saying that I can predict the stock market price, which I would say good luck with that. If they can do that, certainly make a big fortune. If I can do that, right, I'm gonna probably retire from now on. So It's challenging to do that, but can we do it? Not to do the prediction, but can we do a battery, say, operation under this uncertainty without knowing the future price or the future mismatch between the demand and supply? So we have a powerful tool using the so-called reinforced learning, right? We can build, doesn't matter, it doesn't have to be, say, a neural network, but sometimes mostly people use neural network in the middle. Here's a so-called Q network. So I can observe the state, for example, the price outside, and also observe my own like a battery storage level, like energy level. And based on those information, I can decide what I'm going to do right now, to charge or to discharge or to do nothing. There are different choices, and how much to charge and how much to discharge at the grade level, right? A grade scale. So you can get maybe 1 or 2 years historical data and try to train this model, right? Using a training phase and to let the neural network learn what is the best action to do. Then you can actually develop a strategy. In the future, you only need to observe the current state, and then you have an output that to do the right decision. And let's see the output. This is our algorithm. You can see cumulatively, it earns money, right, from this this market. And you can also do like another metric to say that how much mismatch, right, you mitigate. So that's another, the more the better, right? So that's the role of the energy storage here. But here is calculated by money, but it's the same thing. These are the other algorithms. You can see ours kind of double or even several times, right, higher than the other benchmark algorithms. Basically saying that without knowing the future, and you can based on historical data, assuming that probably the price will be quite similar, not for the near future, but in the long run, right? It has the same pattern. Then you can do it actually. So using, again, machine learning based on the data to help you manage the battery, right? You don't need, in this case, to have like an accurate battery model to predict a lot of information and to dispatch, schedule the battery, to operate the battery. You don't need to do that. You can just rely on the data. It's how powerful this nowadays this machine learning and the data science, right, are. And the last example, I just got a few minutes. Yeah. So is we look at not the grade scale battery, which is huge, the previous example. Here we look at the household battery. And here's a real data from in the US. This is how people use their battery to charge. And this is how they're going to discharge. We can still see that, you can see a lot of different patterns. People use the battery differently. So again, this is a diverse energy storage use pattern. And based on this, give us the idea that everyone has a battery, and battery is extremely expensive in nowadays. Though the price declined by quite a lot, still very expensive. So if people use the battery differently, why not let them share the battery, right? We get a community battery and people can use that, and you don't need to have a dedicated battery at your own house, and sometimes you don't use it, right? So this is again a way to reduce, more economical, right? And also reduce the kind of the upfront investment cost. And the answer is yes, we can do it. So with a community, you don't need to need all the users to install their batteries, but they can have a community battery shared by all those users. And certainly the next step is for our engineers and computer scientists to develop how they share and what is the algorithm behind that, right? So we call it a kind of a cloud. So we virtualize the storage resources, and people don't see that is a battery, but they can use the battery resources. and we kind of separate like the right or the from the kind of the virtual world, and people only see the virtual side and just interact with the virtual side, but we have a kind of interface in the middle to connect physical and virtual battery operation. So that is how we do the math. And here's the framework. Well, there's an aggregator running this physical battery, and the user gonna interact with the virtual battery, and the virtual battery decision gonna go to the aggregator, and the aggregator gonna do the physical battery schedule. And this is kind of from virtual to physical and two different worlds, and work together very well. And the result is that we can reduce the needed capacity by a lot, by almost more than 30% in capacity, and more than 40% in the power rate, and reduce the cost by almost a half, and also reduce the user's cost by a lot. So this is a very good solution that people don't need to have their own battery, because we know, based on the data, we know that they're going to use it differently. And why not just have a shared one? I use it sometimes and you don't use it. So we can reduce the capacity needed to save the cost. But we need a very well-designed algorithm to run for this system. Okay, so these works are based on some of my collaborations and some of my own studies, PhD studies. And I want to thank all of them. And here I list a few papers here, and for your reference, if you're interested, and basically talk about this. Yeah, I think that's all I have. It's 1 hour time, perfectly.
Yes, thank you, Dr.
Thank you.
Hao Wang.
Thank you. So I'm gonna stop the sharing.
Yes. Okay, this section. Okay, very good, very interesting topic to discuss. This section is a question and answer session. The first, we have a question for Dr. Hao Wang. Solar panel have developed for 2 years. According to Dr. Hao Wang, does the solar panel have less? According to Dr. Hao Wang, what should be preferred for the implementation of solar panel in Indonesia, and how do we optimize it? Thank you.
Yeah, right. I guess to be honest, I don't know the answer. I mean, to this question, especially in the context of Indonesia. Certainly, I want to know more. And if it's from the technical perspective, I think that's kind of a generic and or different methodologies or different systems and experience from other places can be used for sure. But in terms of policy issues, that might be quite different, and probably, I mean, maybe Happy can be more suitable person to answer that question in that aspect.
Yes, thank you. What if we are in area of high rainfall? Can solar panel be used?
In high what?
Rainfall.
Oh, that's more like a technical issue, right? So about the installation, I don't have really experience in developing that, but I think usually what I learned is I talked to people just recently in Europe, in Delft University, and he's seeing the evaluation of where is the right place to install solar and install wind and all kinds of different resources. And I learned a lot from him that basically is you certainly need to go to the place or from the kind of satellite imagery to have access, to have a kind of evaluation of whether it's suitable or not, based on a lot of different conditions, a very kind of complicated issue, and all kinds of different kind of factors you need to put into equation. And sometimes we don't, and sometimes it's not only those kind of technical issues. Sometimes it's all about others, saying sometimes it's environmental, and also sometimes it's about whether you get access to the main grid, or to kind of transmit the electricity generated from the solar or wind, and quite say complex kind of issue, and it should be very practical and consider a lot of different factors.
Thank you. The next question for Dr. Happy Aprilia. Second question. I'm sorry if my question not relate, but I'm serious. What do you think about global climate case, especially in Asia, like Malaysia or Indonesia? Is it affect to develop of energy and technology? Time is yours.
Okay, thank you, Mr. Karis, for the questions. I'm trying to answer about the global climate change. Actually, it is affecting the policy of energy and also the technology in Indonesia. I mean, the development of renewable energy technology. Because of this global climate change, all of the UN state actually have a amendment in their energy policy, and Indonesian government also have absorbed this issue in the energy policy. That's why our government already made a policy about feed-in tariff and also the electrical vehicle regulation actually. And for the development of energy and technology actually based on the global climate change, like what I said before, we need to act locally. We need to shift our energy to renewable energy. And the resources itself, we need to think about what resources are available in our local neighborhood. I think that's the way. I mean, yeah, the thinking, if we relate with the global climate change issue. I hope it answers your question.
Yes, thank you, Dr. Happy. And the next question for Dr. Hao Wang from Rizi from ITS, Institute Teknologi 10 November Surabaya. Let me ask you a question. What are the conditions is determining the value of payment trending and benchmark costs? And in determining the trend price, does the demand occur every time, every 1 hours per others?
Okay, yeah, thank you for the question. For what consideration, right, for the value of payment trading and the benchmark cost? So there's a systematic framework to compare the so-called your cost, right, in the energy trading case with the benchmark as the outside option, and that difference will be used to determine the payment, and also the payment has to be like a fair one. It's not say someone pay more or less based on nothing. It should be based on the kind of contribution, and also in a fair way. So there's a so our model, our framework guarantees all those different aspects. But for more detailed modeling and what costs we consider, right? So you can refer and you can look at our paper. And for the trading time, right? So that is per hour, but you can do in differently. So hour is basically in the US the the time slot for the day ahead market, but you can have like an intraday market and other different time slots in different cases.
Rezi Delvianti ITS. Any question again? Okay. If nothing question, Iqbal Sugiarto, time is yours.
Okay, thank you, Mr. Harris. Let me introduce myself. My name is Iqbal Sugiarto. You can call me Iqbal. I'm from electrical engineering student at Kalimantan Institute of Technology. First of all, I'm so grateful and thank you to Dr. Happy and Dr. Wang, be able as speaker for the international seminar. This was the best seminar I have attended. So good that I didn't want to go to bathroom for fear of missing the college. Very well presented, honest and helpful. My question is, where is the main challenges and issues of smart grid implementation in Indonesia or Australia, particularly for manufacturers and industrial point of view compared to another country in Asia? And the last question is to Dr. Wang. Does Monash University have a student community about renewable energy? Because also in Indonesia, there is a community usually known as RE, Society of Renewable Energy. If so, is it okay to share stories about student community focused on renewable energy in Monash University? Thank you.
Thank you, Iqbal Sugiarto. Time is yours for Dr. Happy.
Okay, so I will answer first. Please wait a moment, Dr. Wang. Regarding the challenge in smart grid implementation in Indonesia, I think we already started by having many new implementation of microgrids in our outer island. I think this is the plan, have been set up by the PLN. And not only talk about the microgrids in the outer island, actually we also have improvement in the smart meter. But yeah, by having the smart meter implementation in our KWH, kilowatt hour meter, and also by having shifting energy. For your information, Dr. Wang, actually in Indonesia, our energy consumption is heavily rely on the fossil fuel, actually. Still heavily rely on the fossil fuel, especially in the cooking. We still use the gas, and that's why the PLN already states some kind of innovation to shift the energy by having the electric stove or electric equipment more and more in the demand side, like that. So the challenge is how can we move this kind of fossil fuel behavior into the more electricity consumption, like that. And also maybe another challenge in Indonesia is the attractiveness of the feed-in tariff, and how can our government support the investment of the renewable energy integration? Because of the less attractive feed-in tariff, it will not gain more investors to establish a good renewable energy integration. I think that's my answer to Mr. Iqbal's questions.
Yes, thank you, Dr. Happy. Next, Dr. Hao Wang.
Oh yeah, thank you. Can you just repeat that question, because I just didn't pay attention. I just sorry about that. And what's the question about the Monash and the renewable energy community? I didn't hear clearly.
Hearing Iqbal Sugiarto. Can repeat again to question?
Okay, You can repeat. Does Monash University have a student community about renewable energy? Because also in Indonesia, there is a community usually known as Society of Renewable Energy. If so, is it okay to set a story, sir, about student committee focused on renewable energy in Monash University?
You said the Society of Renewable Energy in Indonesia?
I think in Monash University.
Oh, at Monash University.
Yeah, as you mentioned in the earlier, I mean in your PPT, that
Yeah.
Monash University already have this kind of scheme, right?
Yeah. Smart cities, microgrid, we have different. We have also a renewable energy. Well, not a renewable energy. We have an energy institute with quite a people in there and working in this area. And we have like we actually are growing. I mean, in terms of the people we have and the research topic. And we also have like a recent industry program that gonna be for 10 years and provide scholarships to students, overseas students, for PhD kind of opportunities. And that'd be an opportunity. But we cannot right now because of COVID, right? So we are affected by that, and we don't have intake from overseas. But we're gonna open, I think, maybe back to normal after the situation, right? The COVID is kind of well handled globally. And we have energy, a lot of different things related to energy. And when we talk about that, usually it's about renewable energy. So we don't emphasize renewable energy, but most of the energy activities, I think, are related to sustainable energy, basically renewable energy plus battery plus battery management. And it's this huge opportunity there. And we recruit students from all over the world to work with us. And this also can be a good opportunity, I think, for you guys to keep an eye on it. Maybe not only to Monash, but also other schools in Australia and also worldwide.
Thank you, Mr. Howang, Dr. Howang. The last question from Omar Ali Khatami. Time is yours.
First, yes, is my voice can hear?
Yes, can hear.
Okay. First, let me introduce myself. My name is Omar Ali Khatami from Institute of Technology of Kalimantan, from Electrical Engineering. Before that, I want to say sorry if my English is not too good. So I hope you can understand my question. Okay, my question is for Mr. Howang. You had mentioned before in your slide about how to optimize the renewable energy. Is there other way to optimize the renewable energy? That we know the popular renewable energy now is like solar panel. For now, the price is so expensive for the cost, right? We know that solar panel only can work if there's any sunshine. In Indonesia, that I know for the best sunshine is just around 5 till 6 hours for a day. How about what do you think? How can we optimizing that? Is that worth to apply in this era, or is there any renewable energy method except solar panel that we can apply in this era, maybe with cheaper costs? Thank you for your attention. I hope you can understand my question.
Yeah, thank you. Right, certainly, renewable is very location dependent. That's basically, the high level answer. And if you look into it, Certainly different countries need to like have different like policy and different kind of energy plan, right? To really utilize the local resources. It doesn't need to be solar, and in a lot of different places they may not have solar. But the good news is the solar panel, I mean, the price actually dropped by a lot, maybe to like only like 10 or 20% compared to the price years ago. So that's gonna actually help you to reduce the energy cost. That's for sure. So if you have certainly sunshine, good solar potential, that's already a proven say solution for solar to be deployed. So I've been also working with a couple of guys at in South Korea, that we just got a paper recently. We deployed the solar panels in very underdeveloped regions, like in Africa, and let the local to use this local renewable and to power their like basic appliances like light, and that was successful. But in terms of in different places, for example, in the US, you have like maybe 8 or 9 months raining days, and probably that's not quite suitable for renewable energy, but no, for solar. But even in the case you have the sunshine in the summer, and you have certain capacity of storage, the solar panel, it still can make use of it, because the cost is declining very fast. It's very cheap right now. It's very affordable technology. But to have like a better plan, right? So certainly need to look at, for example, maybe the meteorological data, right? Meteorological data about the wind, solar, all those different resources, put them together and to see what's the best option. And also that is also restricted by a lot of different things like geographical terrain and availability of the access to the grid. A lot of different things, a kind of very complicated issue, and the impact to the environment, right? So yeah, so my answer is I didn't see the data, right, from the capacity. I cannot say for sure, but certainly there are many options. And even with some places like in Saudi Arabia, that they have solar for sure. And I visited there like 2 years ago, and the others told me that it's also challenging for them to have solar because of the dust. They're gonna cover the solar panel, right, very quickly. And if you don't, right, kind of erase that, it will be a huge problem. You basically have very low solar generation, right? So all sorts of different challenges, all sorts of different also opportunities. You need to have like a more comprehensive evaluation of your case, but in terms of methodology, to the way to look at this.
Thank you, Mr. Dr. Hawang, for the answer. I think time for Q&A has finished. Thank you, Dr. Hawang and Dr. Happy Aprilia. Hope that the future after this pandemic end, he can visit in Indonesia, in Kalimantan Institute of Technology. Hopefully everything that been explained can be understood by our webinar participant. Because of this limit time, hopefully our explanation today will become knowledge for all of us. Thank you to Dr. Aprilia and Dr. Hawang. Thank you all the participants for joining this webinar. That is all for me. Apologies if any mistake. Assalamualaikum warahmatullahi wabarakatuh. I turn it into the committee. Thank you.
Okay, thanks to our great speaker, Mr. Dr. Hawang and Ms. Yatulia, for the great, useful, and amazing knowledge that have been given to us. And also our great moderator, Mr. Sugiarto. The next is giving certificate virtually to our speaker today. Okay, thanks to Mr. Dr. Hawang and Ms. Dr. Aprilia as a speaker today who have been willing to take time to provide knowledge to the participant of the webinar, and thanks to the moderator, Mr. Haris Sugiarto.
Thank you.
Okay. Well, thank you so much for a great speaker, moderator, and all participants. Hopefully, the knowledge that has been present on this day can be beneficial for all of us. Thank you.
Okay, the next, the most event the LKT has been implemented, which was attended by 47 teams from various universities in Indonesia, and now it has reached the peak of the award for the winners of 2020 LKT IPIN. This is the event we are waiting for, the announcement of the and a poster competition.
Yes, this is the winner of the scientific writing competition. Okay. The best paper is by Wahyu Fitriani, Beta Togito Risma Sagala, Sylvia Arneta Febrianti from Universitas Diponegoro.
Okay, next, the best presentation LKTI Pintel 2020 to Naziatul Hidayah, Dini Afroina Khairunisa, Mia Sofia from Universitas Diponegoro.
The third winner was won by Dewi Rohmatul Hilmi, Amalia Firdaus Iski Rahmawati, and Indra Nur Cahyo from Universitas Islam Negeri Maulana Malik Ibrahim Malang.
The second winner was won by Nadia Tarisdisa Maheswari, Rebecca Christine Jaitan, Jenny Wijayanti Saragi from Universitas Diponegoro.
And won the first place is Najilatul Hidayah, Diniara Kotonisa, Mia Sofiatus from Universitas Diponegoro.
Okay, congratulations to the winners. Okay, the next, the announcement of the winners of the national poster competition, namely Okay, the favorite poster is from Putri Nabila Hilmi and Isa Sakila.
The third winner was won by Antonius Francisco Sinambela and Victor Tobias Jamalil.
The second winner was won by Nurul Aulia and Bunga Amelia Anjayani Putri.
And won the first place is Putri Nabila Hilmi and Raisa Sakila. Congratulations.
Okay, congratulations to the winners, and for those who have succeeded, don't be discouraged.
Yes, don't be discouraged because sometimes we win and sometimes we learn. Once again, congratulations for all winners. Okay, well, it will not be complete if there is no documentation in an event. Therefore, to end the webinar today, all webinar participants are welcome to activate the camera because we are going to have a photo session together. Okay, the operator can guide us in this photo session.
Okay, maybe participants can turn on the camera. Okay, 1, 2, 3. Okay, one again. 1, 2, 3. Okay.
Okay, have we arrived to the end the event international webinar Nasional 2020 Electrical Engineering of Technology with the energy of economic crisis, great solution for the better future, which of course is very important for all of us, as well as for us, and we hope that it in the future.
Okay, don't forget we encourage all the participants to fill the feedback sheet that will be shared by the committee in the chat box. The end of the word. I'm Yosefiana and my colleague.
I am Verly.
We represent the committee in the charts. Would like to apologize if there are some unpleasant words or action that we make. Wassalamualaikum warahmatullahi wabarakatuh. Good afternoon and see you all. Thank you.
Thank you.
Thank you, Dr.
Thank you very much.
Thank you, Dr. Huang.
Thank you. Thank you very much. Thank you for inviting.
Thank
Okay.
you.
Thank you.
Thank you, Doctor.
And visit to Indonesia.
Yeah. If you have time, please visit us in ITK.
Yeah, certainly look forward to that. To look forward to any kind of visiting opportunities, especially to your university. We'll be happy to do that.
Okay.
Thank you. Thank you all.
Thank you.
Thank you.
Thank you, Dr. Wang.
Thank you. Thank you. Bye-bye.
Bye-bye.
Bye.
Bye-bye. Thank you, Mr. Hawang.
Thank you, Mr. Hawang.
Thank you. Bye-bye.
Thank you, Dr. Happy.
Okay, thank you.
Back to Indonesia.
Thank you.
Back to Indonesia, I will. Terima kasih semua.
Terima kasih.
Penyelenggaraannya baik.
Terima
kasih,
Pak.
Tips dulu ya.
Saya juga.
Thank you, Miss Happy.
Ya, sama-sama.
Mr. Haris Sujarto.
Oh iya, terima kasih juga Pak Haris.
Thank you Pak Haris.
Terima kasih, Pak.
Yuk, kita live.
I'm alone, I'm a broken home. I gave you all the bricks that I own and know. I'm I'm letting go. I'm breaking these walls down, breaking these walls down. If you want adventure, then fly to home. But if you wanna travel, then go alone. Yeah, what's the point in us if I never know?
Diawali dari keinginan pemerintah Indonesia untuk memenuhi
Waalaikumsalam.
Take it slow, but it's not typical. He already knows that my love is fire. His heart was a stone, but then his hands rolled. I turned him to gold and it took him higher. Well, I'll be a daydream. I'll wear your favorite things. We could be beautiful. Get drunk on the good life. I'll take you to paradise. Say you'll never let me go. Deep in my bones, I can feel you. Take me back to a time only we knew how to wait. We could waste a night with an old film, smoke a little weed on the couch in the back room. How to wait. Say you'll never let me go. 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 Deep in my bones, I can feel you. Take me back to a time only we knew how to wait. We could waste a night with an old film, smoke a little weed on the couch in the back room. How to wait. Say you'll never let me go. Say you'll never let me go.
Goma lah. Goma. Oh ya. Apa itu ya buat tambah? Ya, tambah sehat saja. Ini mau tambah sehat. Yo awang diabetes kok. Diabetes yo mesti ngono lah. Yang ono luka itu. Aku kan. Iya, diabetes. Ini yo, ukur dia.